When installing a security camera system, understanding the requirements for running video and power cables is crucial. While it is generally not mandatory to run video cables in a conduit for low-voltage security systems, it is recommended in certain situations to protect the cables from physical damage such as impact or crushing, environmental hazards like moisture and pests, and electromagnetic interference. The National Electrical Code, specifically Article 725.50, addresses power cables. This section states that Class II power limited circuit conductors shall be installed in a raceway, an enclosure, or otherwise protected from physical damage. Since the power cables are 12 volts 350 milliamps, they fall under Class II power limited circuits, so they must be enclosed in a conduit or other protective enclosure. It is advisable to run both video and power cables in conduit for enhanced physical protection, reduced risk of interference, and easier troubleshooting and future maintenance. When selecting conduit, use polyvinyl chloride, or PVC, or metal conduit approved for outdoor use. Choose the appropriate size conduit that will accommodate the number and type of cables. Seal all conduit entrances with caulk or sealant to prevent moisture ingress. If running cables and conduit is not feasible due to cost or other factors, there are alternative options to consider. Firstly, use direct burial cables for both video and power rated for outdoor use. Secondly, install the cables in a sealed junction box and bury it in a shallow trench. Thirdly, run the cables along the underside of an overhang or in a covered gutter. Local building codes may have specific requirements for the installation of security camera systems. It is always advisable to consult with a qualified electrician or consult local regulations before proceeding with the installation. Running power cables and conduit is important for safety and code compliance. Because the security system power cables are 12 volts 350 milliamps, they are considered Class II power limited circuits according to the National Electrical Code, or NEC. The NEC requires that Class II power limited circuits be installed in a raceway, enclosure, or otherwise protected from physical damage. This requirement is to prevent electrical hazards such as short circuits or fires that can occur if the cables are damaged. Using conduit provides a physical barrier that protects the cables from being crushed, cut, or exposed to moisture. This protection is especially important in commercial settings where there is a higher risk of physical damage to the cables. While running video cables and conduit is not always mandatory, it is often recommended for several reasons. Firstly, conduit provides physical protection to the video cables, preventing damage from impacts, pests, and other environmental factors. Secondly, conduit can help to reduce electromagnetic interference, or EMI, which can degrade the quality of the video signal. Thirdly, conduit makes it easier to add or replace cables in the future, as the cables can be easily pulled through the conduit without having to disturb the surrounding building materials. The type of conduit to use will depend on the specific application. Polyvinyl chloride, or PVC, conduit is a common choice for outdoor applications because it is durable, weather-resistant, and relatively inexpensive. Metal conduit, such as rigid metal conduit or electrical metallic tubing, is a good choice for applications where greater physical protection is required. The size of the conduit will depend on the number and size of the cables that will be run through it. It is important to select a conduit size that is large enough to accommodate the cables without overcrowding them. Overcrowding can make it difficult to pull the cables through the conduit and can also increase the risk of damage to the cables. When installing conduit, it is important to follow all applicable codes and standards. The NEC provides detailed requirements for the installation of conduit, including requirements for support, grounding, and bonding. It is also important to seal all conduit entrances with caulk or sealant to prevent moisture from entering the conduit. If running cables in conduit is not feasible, there are several alternative options to consider. Firstly, direct burial cables can be used for both video and power. These cables are designed to be buried directly in the ground without the need for conduit. However, it is important to ensure that the cables are rated for direct burial and that they are buried at the proper depth. Secondly, cables can be installed in a sealed junction box and buried in a shallow trench. This option provides some physical protection to the cables while avoiding the need to run conduit. Thirdly, cables can be run along the underside of an overhang or in a covered gutter. This option provides protection from the weather and from physical damage. It is important to note that local building codes may have specific requirements for the installation of security camera systems. It is always advisable to consult with a qualified electrician or consult local regulations before proceeding with the installation. This is important to make sure that the installation is safe and code compliant. Class 2 circuits are defined in Article 725 of the National Electrical Code, or NEC, as power-limited circuits. These circuits are designed to limit the voltage and current to safe levels, reducing the risk of electrical shock and fire. Class 2 power supplies are typically used to power low-voltage devices such as security cameras, doorbells, and thermostats. The NEC specifies the requirements for Class 2 circuits, including the maximum voltage and current levels, the type of wiring to use, and the overcurrent protection requirements. The maximum voltage for a Class 2 circuit is 30 volts direct current, or volts DC for dry locations and 15 volts DC for wet locations. The maximum current is 5 amps. Class 2 circuits must be wired with listed Class 2 cable. This cable is designed to withstand the low voltage and current levels of Class 2 circuits and is marked with the letters CL2 or CL2R. Class 2 circuits must be protected by overcurrent protection devices, such as fuses or circuit breakers. These devices are designed to interrupt the circuit if the current exceeds the maximum level, preventing damage to the equipment and reducing the risk of fire. The size of the overcurrent protection device will depend on the current rating of the Class 2 power supply. It is important to note that Class 2 circuits are not the same as low-voltage circuits. Low-voltage circuits are defined as circuits with a voltage of 50 volts or less. Class 2 circuits are a subset of low-voltage circuits that meet the specific requirements of Article 725 of the NEC. When installing Class 2 circuits, it is important to follow all applicable codes and standards. The NEC provides detailed requirements for the installation of Class 2 circuits, including requirements for wiring methods, overcurrent protection, and grounding. It is also important to use listed Class 2 power supplies and Class 2 cables. These products have been tested and certified to meet the requirements of the NEC. In addition to the NEC requirements, there may be local building codes that apply to the installation of Class 2 circuits. It is always advisable to consult with a qualified electrician or consult local regulations before proceeding with the installation. This is important to make sure that the installation is safe and code compliant. When selecting a Class 2 power supply for a security camera system, it is important to consider the power requirements of the cameras. The power supply must be able to provide enough voltage and current to power all of the cameras in the system. It is also important to consider the ambient temperature of the location where the power supply will be installed. The power supply must be able to operate safely at the maximum ambient temperature. When selecting Class 2 cable for a security camera system, it is important to consider the distance between the cameras and the power supply. The cable must be able to carry the voltage and current over the distance without excessive voltage drop. It is also important to consider the environment where the cable will be installed. The cable must be suitable for the environment, such as wet or dry locations. In summary, the decision of whether or not to use conduit for security camera cables, and specifically the power cables, hinges on the National Electrical Code requirements for Class 2 power limited circuits. The NEC mandates protection from physical damage for these circuits, and conduit is a common method of achieving this protection. For video cables, while not always mandatory, conduit is highly recommended for reasons of protection, interference reduction, and ease of future maintenance. Whether it's polyvinyl chloride, or PVC, or metal conduit, or alternatives like direct burial cables, the goal is to ensure safe, reliable, and code-compliant installation. Consulting with a qualified electrician and adhering to local building codes is always the best practice.